Welcome to today's lesson in physics. Today we are discussing velocity and acceleration in simple harmonic motion. We have already learned the displacement relation in SHM as x of t equal to a cos omega t plus phi. Now, to obtain velocity at an instant of time, that means instantaneous velocity, we have to find the derivative of x, that is v of t equal to d by dt of x. Now just substitute for that x. So we have d by dt of a cos omega t plus phi. Now we have to differentiate this time dependent term alone, and here a comes as a constant, so it can be taken out of the differentiation. So the expression it becomes a into d by dt of cos omega t plus phi. Now when we differentiate cosine function, we will get minus of sine function as the result. So we have minus sine omega t plus phi into a, that is the constant which we had already, into, see, the argument of cosine function is to be differentiated and is to be multiplied with the result we wrote. Okay, so we have that into d by dt of omega t plus phi. So our expression becomes, this is equal to, that means v of t equal to minus sine omega t plus phi into a into omega. This omega comes from the derivative of this omega t plus phi, because phi is again a constant. So d by dt of phi is 0. So d by dt of omega t, that is omega. So we have minus sine omega t plus phi into a omega, or it can be written as v of t equal to minus a omega sine omega t plus phi. So that is the expression for instantaneous velocity in SHM. To find acceleration, we have to differentiate velocity. So a of t is equal to d by dt of v. So we have d by dt of minus a omega sine omega t plus phi. We just substitute for v. So we have minus a omega into d by dt of sine omega t plus phi, because a omega is constant. So we have taken it out of differentiation. Now minus a omega into, we know when we differentiate sine function, we will get cosine function. So cos omega t plus phi, that is the result there. That into, again the argument of cosine function or sine function is to be differentiated and it is to be multiplied with the result we obtained. So that into d by dt of omega t plus phi, as we discussed earlier. So the result of this differentiation is omega. So we have minus a omega into cos omega t plus phi into omega. So finally we have a of t equal to minus a omega square cos omega t plus phi. So that is the expression for instantaneous acceleration. Now in this equation, we just rearrange the equation like this, that is minus omega square into a cos omega t plus phi. But we know already what is a cos omega t plus phi. It is x of t, the displacement relation. So we can write acceleration a of t as minus omega square x of t, or simply we can say a is equal to minus omega square x. The expression for velocity, which is minus a omega sine omega t plus phi, that also we can rewrite in terms of x, as we did in the case of acceleration. So we have v of t equal to minus a omega into, sine theta and cosine theta, they are related by the equation sine square theta plus cos square theta equal to 1. That is a trigonometric identity. So using that identity, we can rewrite sine omega t plus phi as root of 1 minus cos square omega t plus phi. So here we have used the identity sine square theta plus cos square theta equal to 1. So we have minus omega into. So what we are doing in the next step is we are taking that a to this square root, inside the square root. Okay. So when we take something into square root, we have to square it. So when we take a inside, it becomes a square, and a square is to be multiplied with both the terms. So we have minus omega into root of a square minus a square cos square omega t plus 5. And look at this term, it can be written as a cos omega t plus 5 the whole square. And what is this a cos omega t plus 5? It is x. So we have minus omega into root of a square minus x square. So we have velocity v is equal to minus omega into root of a square minus x square. So that is the relation between velocity and displacement. So finally we have the equations. First we have x, that is a cos omega t plus 5, and v, it is minus a omega sin omega t plus 5, and acceleration a is minus a omega square cos omega t plus 5, which can be written like this also, that is v is equal to minus omega root a square minus x square, and a is equal to minus omega square x. Now we will discuss the velocity and acceleration at the extreme positions and mean position. So we already have this expression, that is v of t equal to minus omega a square minus x square. Now at mean position, we know always the displacement is taken from the mean position. So at the mean position, displacement x is equal to 0. So we have minus omega into root a square. So we have what velocity as minus omega a. So the velocity at the extreme position or at the mean position, it will be omega a. The magnitude will be omega a. Vectorially, when we say, it will be minus omega a. The direction will be opposite to that of displacement. That is the meaning. So at extreme positions, we know x is equal to plus or minus a. So substituting, we have that term within square root symbol, it becomes 0. So velocity becomes 0. That means at extreme position, the velocity of the object is 0. So to conclude, we can say that the object has maximum velocity at mean position, and it has the minimum velocity at the extreme positions. At the extreme position, its velocity is 0. Same way, we have the expression for acceleration as a of t equal to minus omega square a cos omega t plus 5, which can be written as minus omega square x of t. So this particular equation has got a meaning. It means that acceleration is proportional to displacement and is directed towards the mean position, because it is opposite to the displacement. Displacement always we are taking away from the mean position. So it is opposite to the displacement, or it is directed towards the mean position. So that conclusion is very important. Acceleration is proportional to displacement and it is opposite in direction to displacement, and it is directed towards the mean position. Now discussing the special cases at mean position, we have x is equal to 0. So acceleration also equal to 0. So the object has minimum acceleration, that is 0 acceleration at the mean position. Now at extreme positions, you know x is equal to plus or minus a. At extreme position, displacement is maximum, that is plus or minus a. So a max is equal to minus a omega square. So the object has maximum acceleration at extreme position and minimum acceleration at mean position. Now we have the graphical representation of displacement, velocity and acceleration. So first graph, we have displacement relation. So we have the cosine curve as shown, and with respect to that cosine curve, when we look at the velocity curve, it is different because the equation is minus a omega sin omega t. So at time t equal to 0, when displacement is maximum, you can see that velocity is 0. And the time when displacement is 0, velocity is negative maximum, that is minus omega a. Likewise it goes. And here we have the acceleration graph also. So at the time when the displacement is maximum, that means positive a, you can see that the acceleration is minus omega square a. So it is negative. That's what we concluded earlier. And when x is equal to 0, acceleration also equal to 0. That's what we say, acceleration is directly proportional to displacement and it is opposite in direction. So this is a very important graph. Note it. Now we have a few problems. First question. A particle executes SHM with a time period of 2 seconds and amplitude 5 centimeter. Find displacement, velocity and acceleration after 1/3 second starting from the mean position. So in the question it's given time period is 2 seconds and amplitude is 5 centimeter. And we are supposed to find displacement, velocity and acceleration at time t equal to 1/3 second. So what we need to do is we have to substitute in the expressions for displacement, velocity and acceleration. And in the question it is mentioned that the object starts from mean position. So we have two equations to represent a simple harmonic motion. X equal to a cos omega t plus phi and a sin omega t plus phi. Here we already took phi equal to 0. So a cos omega t or a sin omega t. Here since it starts from mean position, as I have said earlier, we have to take a sin omega t. So the displacement relation here it is a sin omega t and we have to substitute for t. A is 5 centimeter. So we have omega we can substitute as 2 pi by t, where t is the time period, that is 2 seconds. So substituting we have 5 sin 2 pi by 2 into 1/3. So we have 5 sin pi by 3. You know pi by 3 means 180 by 3. That angle is 60 degree. So sin 60 degree we know it is root 3 by 2. So our answer becomes 5 root 3 by 2, which is 4.33 centimeter. In finding velocity and acceleration, any of the equations we can use. Either the common equation or we have in terms of x, no, that equation also we can use. That is v is equal to omega into root of a square minus x square and acceleration is minus omega square x, like that, those equations or the other equation. So here since we took x equal to a sin omega t, we will proceed like v equal to dx by dt. So we have d by dt of a sin omega t. So we have a into d by dt of sin omega t. A into d by dt of sin omega t will be cos omega t into omega. So the result it becomes omega into a cos omega t. That is the result of differentiation. Omega a cos omega t. Now substitute for omega a and t. So we have 2 pi by t into a into cos 2 pi by t into t. Now substituting we have 5 into 3.14 into 0.5, that is 7.85 centimeter per second. The same answer you will get if you are substituting in the equation the magnitude of velocity. We have omega into root of a square minus x square. In that equation if we substitute for x, which we got from the previous expression, you will get the same answer. Now proceeding like this with acceleration, we have a is equal to dv by dt. So we have d by dt of omega a cos omega t. So one negative sign will come there. That negative sign we are omitting because we are finding only the magnitude. So we have minus omega square a sin square omega t, minus omega square a sin omega t we will get. So that omitting that negative sign, we will write the expression as minus omitting negative sign. So we have omega square a sine omega t. That is the expression for acceleration after doing differentiation. Now we need to substitute. So pi square we will have, because 2 pi by t whole square is omega square. So we have 4 pi square by t square. Pi square, its value you can write as 9.8. So 4 into 9.8 into 5 divided by 4 into sine pi by 3. So 2 pi by t into t it is. So we will get pi by 3. So it is, the answer turns to be 42.77 centimeter per second square. Now coming to question 2. A body oscillates with SHM according to the equation x is equal to 5 cos 2 pi t plus pi by 4. Calculate displacement, speed and acceleration at t equal to 1.5 seconds. So here from direct comparison we need to write the terms. So by direct comparison we'll get omega as 2 pi and phi, there is initial phase, that is pi by 4, and t it is given 1.5 second, and from the value of omega we are getting time period t as 1 second. So first let's find displacement. So we have x is equal to, just to substitute for t in the given equation. Question 1 equation is there, in that just substitute t equal to 1.5 seconds. So we have x is equal to 5 cos 2 pi into 1.5 plus pi by 4. So we will get 5 cos 3 pi plus pi by 4. So how to do cos of 3 pi plus pi by 4? You know, if you have cos theta is the same as cos theta plus 2 pi. It is the same as cos theta plus 4 pi. That is the same as cos theta plus 6 pi. That means that cosine function is a periodic function with a period of 2 pi we can say. After 2 pi radian, the value repeat itself. So here it's given 3 pi plus pi by 4. So that 3 pi we can write as 2 pi plus pi. So effectively that cosine function it becomes cos 2 pi plus pi by 4. So 2 pi, I said cos theta is the same as cos theta plus 2 pi. So instead of cos 3 pi plus pi by 4, we can write it as cos pi plus pi by 4. Cos pi plus pi by 4. Now cos 180 plus theta. What is cos 180 plus theta? In mathematics we have studied trigonometric identities. Cos 180 plus theta is minus cos theta. Cosine and what sine, it remains same, cosine cosine, sine sine. If the relations are involving 180 degree, we have already discussed it, and since it is 180 plus theta, that negative sign will come. Cosine, it is negative in the third quadrant. So we have cos 3 pi plus pi by 4 as cos pi plus pi by 4. Cos pi plus pi by 4 is cos 180 plus pi by 4, which is minus cos pi by 4. So substituting that, we have x is equal to minus 5 into 0.707. That 0.707 is 1 by root 2. Pi by 4, 180 by 4 means 45 degree. Cos 45 is 1 by root 2. That 1 by root 2 is 0.707. So finally we get the answer as minus 3.535. Equal to dx by dt, that is equal to d by dt of 5 cos 2 pi t plus pi by 4. So substituting as we said earlier, first differentiating, we have the final expression minus 5 into 2 pi into sine 2 pi into 1.5 plus pi by 4. So we have 5 into 2 pi sine pi by 4. So as said earlier, there will be 3 pi plus pi by 4, which is the same as pi plus pi by 4. And sine 180 plus theta, it is minus sine theta. So it is minus sine pi by 4. So we have 5 into 2 pi sine pi by 4. Substituting, we have 22.22 meter per second. Now coming to acceleration, again here we have to do the differentiation and applying the result as we said earlier. We have the value 139.56 meter per second. So here if we want, we can directly use that relation between V and X and A and X, which is V is equal to minus omega root of A square minus X square, and A is minus omega square X. Now question 3. A particle executing linear SHM has a maximum velocity of 40 cm per second and maximum acceleration of 50 cm per second square. Find its amplitude and period of oscillation. We know the maximum velocity magnitude, it is omega A, and maximum acceleration, its magnitude is omega square A. So substituting omega equal to 40 cm per second and omega square A equal to 50 cm per second square, we have two equations. So just dividing the two expressions, that means A max by V max, we get 50 by 40 and omega is 5 by 4 radian per second. Now amplitude we get from V max, because V max is A omega. So we get A as V max by omega, therefore 32 centimeter. And period of oscillation, it is 2 pi by omega. So we get 5.03 second. Now question 4. A body of mass 0.1 kilogram is executing SHM according to the equation 0.5 cos 100 t plus 3 pi by 4 meter. Find the frequency of oscillation, initial phase, maximum velocity and maximum acceleration, and total energy. Actually energy in SHM we haven't discussed, but for the sake of completion of this problem, we will just discuss that equation and find the answer. So here from the given equation, by direct comparison, we have A is equal to 0.5 meter, omega is 100 radian per second, and phi 0, that is the initial phase, that is 3 pi by 4 radian. So from the expression for omega, we get frequency, which is omega by 2 pi. So 100 by 2 pi, 50 by pi hertz. Initial phase, it is we get directly 3 pi by 4 radian. And V max, we have omega A. So substituting, we have 50 meter per second, and A max, maximum acceleration, as omega square A. So 100 square into 0.5, that is 5000 meter per second square. Now what is total energy? We just use this equation, half m V max square, that is half into 0.1 into 50 square, that is 125 joule. So only this much for today. Thank you.